Welcome back, folks. The inverter I've got on the workbench today is an old one, but it's a good one. Or it's been good for me. It's a Chicago Power Electric Systems I bought from Arbor Freight probably 10 years ago. It's 2,000 watts continuous, 4,000 watts peak. I am almost certain this is a modified sine wave inverter, and that's why I chose it to be next in line. It has 3 cooling fans. 2 on the bottom, 1 on the end. Got some big old lugs on the end of it here to carry the current to run 2,000 watts continuous, and it needs them. This is 2 gauge wire connected to it that I'll connect to a car battery. I bet these wires are going to get pretty warm when we run the full load on it. So I got 2 plugs, an amp meter, a voltmeter, overheat and overload, and on-off switch. So let's get it hooked up. One characteristic often overlooked with inverters is how much current does it pull when it doesn't have any load on it. I'll call it idle current, but this one's got 3 fans that turn all the time, and so it's going to pull, regardless of load, it's going to pull at least 2.5 amps at 12 volts. So this may not be an ideal inverter for an off-grid solar powered setup. All right, for the load test, we're going to start out with 1,000 watts, just halogen bulbs, and then I'm going to add to it till we get to 2,000. After the load test, we'll see what it does with a couple of inductive loads, see if it runs all right with those. So let's get going. All right, a very modified sine wave inverter. Pulling about 953 watts right now. That battery is not fully charged, but it's still sitting on 12 volts. So I think it's enough for this demo. Let's see. All right, there's a space heater on the low. Medium. And the high. What are we looking at? Oh, we're already over 2 kilowatts. We're 2,000, I guess that's 2,070 watts, 2,060 watts, 109 volts. That's all right. I'd like to see 120, but there's nothing wrong with that. So it runs 2,000 watts. So I've got a skill saw plugged in and the little laser light's on. Looks like that's pulling about 3 watts on the right hand side, on the right hand meter. So I'm gonna go ahead and turn on this 8-inch bench grinder. I'm gonna turn off some of these lights though. All right, so we've got about 500 watts of load on the inverter now. I'm gonna turn on this bench grinder. Ooh. So, pulling a power factor of 44. You'll hear that hum. That hum that's coming off the grinder. I forgot that it takes forever for this grinder to shut down. Let's see if we can hurry it up. That's better. So that characteristic hum is an artifact of this modified sine wave that we see here on the screen, or these electrical pulses. The motor is an inductive load. It wants to hear or see a sine wave and not a modified sine wave. So it doesn't really like that modified sine wave. All right, let's see if it'll run a skill saw. Okay, so the skill saw likes it just fine. Of course, if there were any hum, you wouldn't be able to hear it anyway over the saw. But that's the thrill with an inverter. It either runs a load or it doesn't. So this one runs 2,000 watts. It runs inductive loads. We'll let it cool off and then get things shut off. So this about wraps up our first look at a modified sine wave inverter. If there's anything else you want to know about them, send in your comments and questions below. If you like the video, subscribe, and I'll see you next time.